Hi everybody, welcome to today's class. Now in this class I shall discuss a very important topic for all the chemistry students. Now just before going to this, let us consider one thing. If I ask you to draw the picture of a house, will you be able to draw this picture properly? Yes, I know. Some of you will definitely be able to draw a picture, but some of you will not be able to do also. The question is why it is so difficult? The answer is the house is a three-dimensional thing. That is, in order to make a house you have to consider three dimensions. One will be length, another will be breadth, and another will be height. Without considering these three dimensions you will not be able to construct any house. But if the house is to be drawn on a piece of paper, then what difficulty you will face? Yes, the difficulty will be regarding these dimensions, because your page, mostly the copy, will be three-dimensional, because it will have length, breadth and height also. Maybe the thickness may be less, but whatever may be the case, there will have some thickness. But if you consider only the page will have two dimensions, length and breadth. It will have no height. Similarly, if you want to draw the house here, then what will happen? You will get two dimensions here, maybe this one length and this one breadth. But if you come in this side, it will be height, and it is not available to you and to me also. Now in this, the problem arises. Now similar thing happens if we want to draw the picture of any organic compound, because most of the organic compounds will be three-dimensional in nature. So the question arises, if we have to draw this thing, if we have to draw a three-dimensional structure or three-dimensional molecule on a piece of paper or board, how to do this? Now before going to this, let us consider the model of a compound. Look at this. This is a compound. This is a three-dimensional structure. Now how this is a three-dimensional structure? Look, in this structure we may draw a plane through this and this. So it will be like this. Now if it is so, then this portion will be closer to you and this portion will be away from you. Now before going to this, let me introduce this compound. This is the structure or three-dimensional structure of methane molecule. We know methane is the simplest organic molecule, so it is better to start with this simplest molecule. Now if you are asked to draw the structure of this three-dimensional molecule on a plain paper or the board, then how to do this? Now in this, three conventions will be there. First of all, you have to take some atoms which will be on a particular plane. Now if we consider this and this to be present on this plane, then this bond and this bond will be represented by normal lines. So let me draw this. The central carbon atom, let us consider this hydrogen here and this hydrogen here. So this hydrogen, carbon and hydrogen, that is hydrogen, carbon and hydrogen respectively, are present on this plane. Maybe if you draw this on your copy, then also similar thing will happen. Now what to do with this one and this one? Look, what is the difficulty with this? The difficulty is that this one is nearer to you and this is not lying on this plane. Okay, and similar type of difficulty will be here, because this is away from you, this is beyond this plane. Okay, maybe backside of this plane. So this is even far away from you. So regarding this and these, two type of conventions are there. That is, if you want to draw the picture of anything, any bond, any atom which is nearer to you, which is above the plane, above this plane, then it will be represented by solid wedge. And let us consider this in this way. So this one we may represent in this way. We are considering one solid wedge for that, and we are drawing in this way. So this is the solid wedge which is representing this hydrogen which is above the plane and which is nearer to the viewer. Here the viewer is you. So this will be for this one. Now come to for this hydrogen. What will happen for this hydrogen? Since this is away from you, so it will be in the rear side. Now let us consider one general thing. Whatever thing we see in reality, any substance which is closer to us appears larger, and any substance, if the same substance even is taken and it is far away from us, then we see this one smaller. That is, it actually it is the same, but it appears to be smaller. Now here also the same theme should be applied here. This one, it should be smaller in shape and it will be represented in such a way that it is reflected here, and for that the convention is to write down this one with dashed wedge, and it is like this. Maybe like this. This may be drawn here also. This may be drawn here also. So look, in this two more things are there. That is, look, in this the broader side is here. Why? Because when you are seeing this one, this is closest to you. So this is hydrogen. This is closer to you. This portion is away from you. So as you move from here to here, in this, as you move from here to here, you are going gradually far and far. So you will see lesser in this side and much in this side. So this one is broader, and as you move it will be narrower in nature. Now what will be for that? Now this carbon and adjacent portion is closer to you. So this is the closer portion to you compared to this one. So as you move away from here, so you gradually you are going far and far away. So the bond is becoming narrower in nature. So if we represent in this way, it indicates that this portion is closer to the viewer and this portion is away from the viewer. So is it okay? So in this way we can represent a compound on a 3D manner on a 2D plane, maybe on a paper, maybe on board. So in this way we can represent the 3D structure. Now let me consider another compound. This was the simplest compound, named methane, and formula is CH4. But if we want to draw another compound, let us consider CH3 bond CH3. This is the second hydrocarbon. This is the name of the molecule is ethane. Now what is the difference between methane and ethane? Now in this, if we represent this one in this way, then this is also CH4 altogether. Now what is the difference between these two? In methane structure, if we replace this hydrogen with one methyl group, then we get ethane molecule. So any of the hydrogens, if replaced by CH3 group, then automatically it will be the 3D structure of that molecule. So let us consider this one, this hydrogen be this hydrogen, and if we convert this one into CH3, then it is becoming CH3 bond CH3, like this, CH3 bond CH3. So this is becoming 3D structure of ethane. Now this is the half portion. Here half portion we have shown 3D, similar thing will be here also. This is also 3D, and these 3 hydrogens can be represented in this way also. Okay, I am not going in this again because we have already drawn one carbon atom. Exactly similar thing will be there also. So in this way we can represent the 3D structure of any molecule on a piece of paper. Now this was very important, because if you are asked to draw any compound in 3D manner, or if any 3D structure is given to you and you have to identify, you have to explain how this happens or what do they indicate, then you have to know this one. Now before closing this one, now just let me mention one thing. This was one part of structural presentation of organic compounds. Now before that I have discussed another very important portion, which is how to write down the structural formula of organic compounds. You can see here it is already written, the structural presentation, the first part rather it was, and here 3 ways were there. What are they? Complete structural formula, condensed structural formula, and bond line structural formula. I have discussed all these 3 in the previous class. The video is already uploaded, so if you want to know this thing, I recommend you strongly to go through this also, because in that case you will have thorough idea about this one, and today I hope you have now thorough idea about this one. So combining these two, you will have clear idea how to present structural formula of any organic compounds, or how to represent any organic compound, maybe formula wise, maybe structure wise. So that's all for today. I hope this class is effective to you, and if it is so, please subscribe this channel, and if you like this, then please press bell icon, so that once I upload any video in this channel, you will immediately get the notification and you will have access of these videos. So that's all for today. Bye bye.